This week, UK Science Minister Jo Johnson was in Cambridge, where he announced an initiative to pump £21 million into 7 key research programmes intended to tackle some of the leading scientific and engineering challenges facing the world today. The funding will come from the UK's Engineering and Physical Sciences Research Council, the EPSRC, and Professor Philip Nelson is the EPSRC's chief executive. He joins us now. Hi, Philip.
Hi.
Tell me a little bit about how you decided what these 7 research programmes are. What are the big challenges?
Well, we went through quite a detailed process of consulting many of the folks in the engineering research community. And of course, we have a very strong community of researchers in the UK. We really are world class in this field. So consulting the community and government and industry, we held workshops across the country. We wanted to involve as many people nationwide as we could, really thinking through what the challenges for the future are, where engineering can really help and assist in making the country more productive, resilient, healthy, and better connected, better joined up.
And what sort of fields have come out of this? What are some of the questions that have been raised through this process?
In the first instance, we actually defined about 4 challenges that we felt were important. Firstly, water, sustainable engineering solutions to provide water in the long term. This is a critical part of our infrastructure, and we want to make sure that we can sort of link our distribution of water, make the whole business of treatment, purification, reuse, put it all on a very sustainable basis for the long term, minimising energy consumption. That was one challenge. Another was engineering approaches for cities. When we build cities in the future, getting the balance right between engineered natural systems we felt was very, very important. I think there's so much of the world's population will be living in cities in the future. So actually making them work really effectively as places to live and work was something we felt was very important.
And is there anything that's not about kind of big infrastructure? Are there things that are a little more sort of on a small scale, or are they all these big kind of projects?
No, absolutely. One of the other challenges we came up with was actually, we call it engineering across length scales, from atoms to applications, because we're doing some fantastic science in the UK right at the atomic level. So things like the discovery of graphene, you've probably heard about, this fantastic monolayer.
Oh yeah, we've done a show on graphene.
You'll have done that. Well, I think there's great possibilities in what we can now engineer at the atomic scale. The big challenge is making it scale up to things that are really practically applicable at the larger length scales. So actually joining these together is another of the grand challenges we put out there.
So the EPSRC is putting £21 million into 7 of these big projects. Now, sometimes it's hard to think, is that a big amount of money or not a big amount of money? That sounds like quite a lot of money to me.
It is quite a lot of money, but we actually commission research annually to a value of around £900 million a year. And again, that's what leads to this great strength in science and engineering in the UK, that we have this great base of fantastic scientists that do this great work. So sustaining that investment is absolutely critical for the future of our economy. It's fairly well established that investment in science and engineering will lead to economic growth, and we think it's a crucially important endeavour to make sure we back the right sorts of projects.
And what do you expect to get out of this? How will you know, very briefly, if this approach has been a success?
Well, for example, one of the projects that we're funding is led from Cambridge, and that's about managing air quality in green inner cities. The whole idea there is to provide basically a modelling capability that links together the way the air moves around a city with the way it moves around buildings. Can we design buildings more efficiently to consume less energy and air conditioning? Can we use natural ventilation? Can we understand the way pollutants, that you've heard a lot recently about pollution in cities because of nitrous oxides and so on. Yeah.
And so hopefully we'll all be breathing much easier in the future. Thank you very much. That's Philip Nelson from the EPSRC.